Okay, class, continuing from where I stopped yesterday, we are going to look into the other part of the same question, the part B. Now, so in the first part of the question, it asks you to calculate to sketch a graph. So let us sketch a graph. This graph is a V-shaped graph. It has a sharp corner at -2. Okay. Actually, from the graph, you could probably have guessed that the graph is not differentiable at -2, no? Right? You probably have guessed that. So now it wants you to show by calculation that g prime -2 does not exist. Of course, as I said, from the graph, it is actually quite a telltale that you can see due to the sharp turn, the gradient is not defined at -2. But to do this by calculation, right, you have to actually carry out the calculation of g prime -2. Do you remember how to calculate g prime or f prime at a particular point? It will be the limit as x goes towards -2 of gx minus g of -2 over x minus -2. Right, so this is by what we discussed yesterday. This is how the gradient of a function at a point is to be computed. And given that gx is defined differently over the left and right side of -2, to calculate this limit, we have to actually do it in two parts. By the way, you want to note that g of -2, this one is actually 0. That's why in the next line, the g of -2 disappears. So now what's going to happen is, I now have to actually calculate the left and right derivative. Sorry, the left and right limits of this. So I'm going to calculate that. I'm going to calculate this one. The limit as x tends towards -2 from the left. So from the left, right? From the left, when you open up the modulus, this becomes negative of x plus 2, and then this ends up as a -1. Then on the right side, when x goes towards -2, it's good to put -2 in brackets, -2 plus. This will give you x plus 2 over x plus 2, which is 1. So therefore, the left and right limits in this case do not exist. Therefore, we conclude that this one does not exist. Okay, so important reason, right? Since the left and right limits are unequal. Okay, maybe not the same. Are not equal. Okay, are not equal to each other. Okay, so that completes the prove that g prime of minus 2 does not exist. Okay. The space below that is actually for you to work it out, just like I work it out on top, right? So here you put a remark no, that if the second line, sometimes people call it the second line, some people call it a quad. If the second line does not approach a unique limiting position. So what's happening here is this remark says actually if you try to draw a tangent line at this point, you're not sure whether you should draw it this way, to draw it this way, or to draw it this way. There are many possibilities. So for the reason, right, you therefore can tell geometrically that the gradient at the point is not defined. Question to raise? Anyone? Okay, Skype, okay. Right, let's press on to example 6. Okay, why don't you try example 6 now? I'm going to slow down a bit so that I can actually hands-on, you know. Right, you can hands-on a bit. Yeah, do you have a pencil? I heard him say that. You didn't bring a stationery. Okay, it's okay. Right, one of those times. Actually, I'm hoping to tell the class that let's go fully digital. After the Chinese New Year, can you all come back to class with your PLD, right? And then I can send you a PDF version of our notes, and then you write on your iPad.
This link is acceptable as a method for writing.
No, only for class lesson now. But I said we can't do that.
Anything you want.
Huh?
You can use any format you want to write.
Yeah.
But usually they take time to get your part.
Okay. Anyone here has a problem with digital device to you know? So which means they come to class, right? They come to class, all of you have a PDF version of chapter 2 notes, and all of you writing notes the way I write mine. Would it be interesting? And then you go fully digital, no? And I'm trying to also mark your assignment digitally. I have scanned your assignment, I know. For those who don't need to meet, so I tend to do it digitally.
So I prefer using the paper.
Yeah, same.
Paper I just
Sure, it's a preference. Just that I'm trying to nutshell into it. Because your generation is the digital world, your generation.
Debatable. Some of us still prefer to use paper.
You want to slowly move away from it, no? I'm also at first very reluctant, no? In fact, I went through education where my teacher would write every word on the board, you know? So I was so accustomed to this, no? So there was always this resistance to change, you know? But I find that after some time, it's very convenient, you know? For one thing, I cut down on the use of markers. That helps the environment, actually, you know? And then another thing I realized is I can archive my thing up at no cost. Of course, you have to steal, I know. But I think that it take away the cost of printing, take away the cost of flip here, flip there. Right? So I leave to you as a decision for yourself, but you want to slowly be brave to embark onto the digital era. Okay, so the first statement that you always start out with is like that, you know. It's always like that. Of course, nothing stops you from using the other version of derivative. Okay, so given this, you want to bring in the value of f1. What's f1 equals to? f1 is actually 1. In this function, right? In this function, because it is defined differently on the left and right side of 1, we therefore have to go through the same motion again, and that is we define the limit as x approaches 1 from the left. From the left, right, the function to use is 3x minus 2, and then so of course it's minus 1 over x minus 1, and then you will get a value of 3. And then on the right side, limit, this will give you x cubed minus 1 over x minus 1. And someone told me that there's a formula for factorizing the cubes, the difference of two cubes.
It's x minus 1.
Thank you.
It's x squared plus x
Good.
plus 1.
Right. And then you want to be very conscious about this cancellation, though, that this cancellation is valid because this cancellation is valid because
It's not equal. Sorry, one is not x, so it's not.
right, very good. And then this gives you a value of 3 as well. So for the reason, this is 3 by 1 and 2, right? Because the left and the right limit are the same. Okay, so with this, you want to move on to this. This is a interesting exercise now. Can you hand sketch a graph which is continuous and differential at the point x equals to a? So you can draw a graph that looks like this. Like that. Say maybe there's a point A. It need not be at the turning point, no, it need not be. As long as the graph is continuous and is differentiable. How do you know it is differentiable? Geometrically, if it looks like a smooth curve, no sharp corners, smooth. So sometimes this word is used to describe it, no? Smooth. No jaggedness, no sharp corners, smooth. So when the graph is smooth like this, at the point A it is continuous and also differentiable. How about a graph that is continuous but not differentiable? One possibility would have been like this. We know the V-shaped graph is a popular one that we can use as an example. Right, it is continuous, but it's not differentiable. Something that's not continuous and not differentiable. Okay, maybe like this. Right, like this. Such a graph is certainly not continuous and not differentiable. The last one. So you have a class rep nominated already?
No.
Okay, so Kenneth, you have a class rep last year?
No. 月饼
Who?
月饼
Yue Bing. Yue Bing. So can you have the setting plan with the names, no?
And we just did UC.
Yeah, we just ready.
Okay.
So,
So I used to know that Wen Kai used to sit there, and then Kai Wen will be one space, and then Euler after that Kai Wen, you know. So now Kai Wen is here. Where is Wen Kai? Yeah, Wen Kai is behind now. And where is Euler now? Okay, all right. I know you're not Raja. Okay, Kurtis, tell me how do you draw such a graph? Okay, let's have Kurtis to come to the board and draw for me the fourth one. Come, Kurtis.
Really don't. Because the thing is, there is no, reading through the notes, there's no point in time where it says a function has to be continuous to be differentiable. There isn't a mention, and we know how specific the note is. At the point, I'm genuinely confused. I don't know whether that's the case.
No, it's not here. It has to be continuous the open interval. Then you can differentiate it in the open interval.
No, I'm pretty sure that's like
This is not continuous. This one is not continuous, but is it differentiable? Okay. Let's check this out. Okay. Let's take example. So allow me to. Okay. Thank you very much for the example. Let's. Okay. Let me take an example and then discuss here. So if you allow me to come up, use this example, Kurtis says I have, say maybe at this point 4, his graph like this. So let's call some 5. So the point in question, right? The point in question maybe is minus 3, okay? Minus 3. So it has a function that is defined like this. So maybe this line is y equals to x. Okay.
why that's why.
Okay, so this one not before. This will be 3. I think minus 1. Okay. Let's change this number. Let's call this one okay. Negative 7. Okay. Okay, let's draw it far down, okay, let's draw it far down. Right, so let's see again, is this function differentiable? It's of course not continuous, is it differentiable? So let's try again, I'm also keen to know. So to find the derivative at x equals to 4, by definition is limit x goes towards 4 of f of x minus f of 4. Okay, let's check it again. This is the definition, you know. Okay, so there's going to be limit. Okay, so it's going to be x minus 1 minus 3, is it?
No, minus 7.
At 4 is 7, minus 7. Minus 7. So it's x minus 4. Okay, then limit as x goes towards 4, this is x plus 6. And your classmate here, Mahil, was saying he learned it well. He said he learned it as rule of thumb that if something is discontinuous, right away it is not differentiable. No? This is a truth that you want to now embrace. That if the function is not continuous over there, it can never be differentiable. Okay. So what happened here is this question here is actually a trick question. This is actually not possible.
My intuition was correct.
In another word, right? Continuity is a needed condition. Okay, it's a necessary condition. You know? Continuity is a necessary condition, right? For you to have it first before you can even talk about differentiability. right? It's a necessary condition. So if this right with this, we want to actually move on. We are going to establish this result more formally later. But in the meantime, this for entertainment. It was added in some years back by someone. Is to with the hope that it can instill into students the way to read graph and apply calculus in this graph line. Over here, it shows you two diagrams. No? One is actually the case of a man's lifespan. Is it lifespan, right? Survival probability. Okay, probability, and then versus the I think the number of cigarettes. Or age, teen age. Okay.
As you go older, what's your
So if you're a smoker, right? You're a smoker. If you're a smoker, right? Okay, you're a smoker for the case of man non-smoker and man smoker, right? What it says here is if you don't smoke, right? So when you're 70 years old, your probability of survival is something like 0. Near to 9, right? Near to 9. But if you smoke, your survival probability dwindle down to maybe 0.7, which is not good like that. So it means if you're a smoker, right, you have a lesser chance of living past 70 than a non-smoker. That doesn't mean that that you will not live past 70, maybe not. It's just a probability thing, you see. Because there's one person that I know of who smoked his whole life, but he lived till 90 plus. And that was actually the former leader of China, Mr. Deng Xiaoping. He lived a good old age. He died at a good age. He died just before Hong Kong was returned to China. Yeah. I remember that part of history. Okay. And then interestingly, in this chart, what I find is, for the case of men, smoker, the dotted red line just dwindle now quite smoothly, But for women, what's interesting is, if you are a woman's smoker, it shows if you are actually near just over 70 years old, right? Your survival probability dropped drastically, I do not know why it's like that, Yeah. Okay. In any case, this chart, when you apply your understanding of calculus, you find that the drastic change over here tells you that that women who smoke, your probability of survival drops quite quickly. But of course, you look at the chart for men and women, men generally will die faster. Right? Okay. Singapore, I was told, the average lifespan of a person in Singapore is over 80 years old. That's not bad, it's quite good. Right? So you can have, I just count, you're only 18. You got a good, at least 60 over years to live. You know what I mean? Ahead of you, and can do a lot of great things. Okay, don't have to answer these two questions. Okay, it's just entertainment, and also to tell you the harmful effect of smoking. I don't hope to see that my student will leave school and one day start smoking. In fact, I've never seen any of my students from NUS High ever. Okay. Let's move on to this. Over here, right? We want to actually discuss the relationship between differentiability and continuity. In this theorem, it wants to establish that if a function is, then this statement wants to establish that continuity is a necessary condition, right? So we are going to do a proof of this. So if f is differentiable, f is differentiable at x equals to a, right? What does it mean? It means this limit exists, right? And then using this result, we want to establish something. No, we want to establish that it is continuous. To establish that it's continuous, basically I need to establish that this is the case. Okay. So you understand that from the first blue to the second blue is where we want to write down the proof. So the way to start off is, I intend to first and foremost calculate the limit of this. I hope to eventually show you that this limit is actually going to be 0. Okay, this is my intention. I intend to show that this limit will be 0. To do this, and in order to make use of the thing above, what I need to do is, I'm going to introduce x minus a below, and therefore I times by x minus a. Now, because of the blue color above, I can therefore be assured that the limit of this fellow exists. And for x minus a, the whole world knows that the limit of x minus a will also exist when x goes towards a. It's quite straightforward. So therefore I can rewrite this thing as a product of the two limits. Okay, now we have the blue color that says the limit exists. If the blue color limit exists, it therefore means to say this number, right, is some finite value, right? But at the same time, what's the limit of x minus a as x goes towards a? Answer is 0. So therefore, this is 0. So step 1, we have shown that this is actually 0. Okay. Then the next thing is, we now want to calculate this limit. Remember, we want to show that this limit is equals to just fa. Okay,
I mean you already got equals 0 already, right? It's just a matter of splitting up the two and then just putting the fa.
Yeah. So let's draw on Kenneth's point of view. Allow me to use a new page sheet. He raised a very good point. Very good point. Let's discuss this point together. Kenneth says, I already have established this result. Kenneth say, why don't I just split up like this?
Yes.
Right. And then I conclude that this is, and because FA is defined, right?
Yes.
So therefore, this is just FA. But this one has a problem, Let's hear from Kai Wen. No, Wen Kai. Wen Kai. What do you think is wrong with this calculation? Okay. The issue of this portion here is that from here to here cannot continue. Why is there a problem? Yeah, because by so doing, right, you already assume that this limit exists.
Oh, we don't know that it exists yet.
We don't know. We are trying to find.
Oh, yeah, I
That's why
we know it exists.
Yeah, that's right. That's right.
Oh,
So,
okay,
so because of this, absence of this information, we therefore can't jump to a conclusion.
Yeah.
We now want to do a bit of calculation. Limit x goes towards A. Okay, Wen Kai, you can't hide yourself now, I can see you, Yeah, even hide yourself under the hook, I can still see you are right in front. Yeah, no, Kai Wen, sorry. Mix up. Next up.
I was like, how was Wen Kai hiding?
Okay, Wen Kai is not hiding. Okay, so if you write this way, then it's easier because I know that this is true. Why is it true? Because I've established earlier on that the limit of this law exists, and you also know that the limit is actually 0. This limit, remember?
Okay.
Number one, right? Can you see number 1? The calculator is 0, see? So that means the limit exists, so now I can split the 2, and then this therefore gives you just f of A.
Kind of confused.
Okay, slowly. Let me rewrite. Okay. So from this line.
How do you know that it exists?
Yeah, we calculated in number 1.
Number 1 you already said that equals 0. So
Yeah.
fx minus fa exists.
In number 1, we have established this result that it's actually 0, right? So therefore, this gives you 0 plus f of A, and therefore fa, and hence f is continuous at x equals to A. Okay, so put a remark. Can put a concluding remark. Make a concluding remark. Okay, I'm going to put it here because no space. Hence f is continuous at x equals to A. Let's put a concluding remark. Career, you got thing to raise? 建平 right? 建盆 可以啊 建盆 are you local? You're local, right? Are you local? Yes, you are local. Okay, I guess it's not.
Why?
He is right, he's a local, right?
Why?
Okay. He has a bit of a he looks a bit not non-local. That's why I'm asking him. A bit. Sorry about it. No, my wife's from China. Just in case you think I'm racist against China. My wife's from China. So my daughter actually grew up in China. My own daughter. Why I say? Because in China, when a girl attended kindergarten, a lot of the boys have the hairstyle like yours. Really. Yeah. It's a trend, I know the trend. Chubby, and then they run around. Okay. So don't take offense in that. I'm alright with that. About looking like mainland Chinese. They're very prosperous nowadays. No? If you've been to say Shanghai, Shanghai is very, even better than us. To be honest, no? If you've been to Shanghai, you know. They're even more prosperous than us, no? I think, if you've been there. Yeah, we actually be learning from them now, no? They're very wrong, Okay, let's ask fill in the blank. So, obviously, I have to pick Jian Peng to fill in the blank. F is not continuous, then F is brilliant. The converse of the theorem is not true. That is, if F is not continuous, it potentially if F is continuous, right? It may still not be differentiable. No, remember we had example just now, right? Continuous but not differentiable. Okay. So the way to describe this is continuity is a necessary condition, but not a what condition? Not sufficient. That's right. Continuity alone doesn't assure differentiability. But without continuity, you can't have differentiability. Okay. Right. So the paragraph below is trying to reiterate the same thing. Okay. Now this question wants you to do this to show that it is non-differentiable. What do you have from 9:30 to 10?
PE.
Where is still go for P?
I don't know.
P is 1 hour or 1.5 hour.
It's 1 hour then 10.
9:30 to 10:30 go go to the hall.
Some genius decided that it's a good idea to go into aircon room after PE. Not even just
Because some people quite dressed up, is it? Some people quite dressed up for occasion.
Why ask for early leave when you guys straight out ask for leave?
Why?
Huh?
Okay.
Why bother going PE?
Chen Yan take us through number 7.
But it's got half the name, right?
Yeah. I told my daughter's name, right? Did I tell you my daughter's name? Yeah. It's very nice. Right. Chen Yan, come.
Like ethics, I mean, the conscious ethics, not continuous and zero, because like the left and right hand limits are like different.
I'm just jotting down what you say, right.
It's not equal.
What's the left limit equals to?
So that limit equals to 1.
Okay. Thank you for that. So yeah, that's what's going on. That's great. Do you believe me that if you were told in a young age, right, that math doesn't need memory work, do you believe this?
I mean,
Yeah, like addition, subtraction, I'm sure you know, like multiplication, division, you know, algebra, you know.
it becomes habit more than memorization. Because you by default know 1 plus 1 equals 2.
It's a half truth, you know. It's a half truth. Because if you can memorize these formulae, right? If you can memorize this formula, it's like kind of hard to do, you know.
If you can't memorize the formula, you can just derive it on the spot.
Not all can be derived so easily. You don't believe me, class. You don't believe me, you try to derive every one of them. I'm very sure in this class, I'm almost sure, okay, none of you can prove everyone from first principle. I'm almost sure.
Can prove it.
Not all of you can prove all these from first principle.
I know 1 and 2 can.
I'm not trying to belittle you. Some of them are quite hard, you know. Some of them are quite hard. Okay?
Yeah.
You don't believe me? At home, you can try this fella. You can try. It's not so straightforward, you know. It looks easy, but it's not. Right? So in any case, class, what I'm trying to impress on you is actually to say that math is totally without memory work, I think it's a half truth. If you look back in the case of trigo, improving trigo identities, if you have not memorized all the trigo special angles, you have not memorized all the trigo identities, you find that it's quite hard to prove the identities on it. Because if it's not in your mind, you probably will not think of those identities. You believe me? No? So from young age, right, you should have this change in mindset, no? That actually you are required to remember some hard facts. You have to. If you don't, so you find that sometimes you don't think as fast, or you won't even think in the direction, you know. Okay, now to test you out, hierarchy, right? What is the differentiation of secant x? Differentiating secant x. Secant.
Secant is
Brilliant. Euler. What is the differentiation of cosecant x? Cosecant x.
No. You just convert in cotangent x and sine. Wait, cotangent. Yeah. Wait. Negative cotangent x. Right.
I think you're there. It's negative cosecant x, cotangent x.
Yeah.
Alex is in front of me. He was actually.
Change my name already here.
I was like, Canon. He was actually working through his mind. But in working through his mind, he actually recalls some of the basic formulae. So that goes to show actually you need to memorize some formulae. Right?
I think at some point it just becomes by heart.
One thing I want to be sure. Aiden, sine inverse x.
1/1 minus x.
Brilliant! Yeah, right. So class, you have to faithfully memorize them, Okay, I told the story about the German guy and the British guy, Newton invented a lot of math, really. Without him, I think there are cars, Okay, notational thinking. I suspect it's more of this notation rather than what is written here. It's more of this kind of notation. I'm not sure about Newton's notation in this manner, but I'm very sure in Newton's books, right? He always used such notations. Okay, in any case, you have the chain, product, and quotient rule, which you learn in your lower years. You should go and read out about the proof of these three rules, Yeah. They are not exactly very hard to prove. They are all based on the same principle, the definition of differentiation. Okay, for this word example that comes up now, it's kind of an easy question because you all know how to differentiate this, right now. Let me hear from someone. Brendan, hx, how do you differentiate hx? How do you do it? Do you differentiate the inside as well, right? Do you differentiate the inside as well? Yeah. So there's actually chain rule. Now, why does chain rule work? Now, chain rule, if you look more carefully, chain rule is actually class. I want you to look at the left hand side. Left hand side. If you study this working on the left hand side, class, this left hand side, I want you to begin to realize chain rule for the differentiation of this, right? Using chain rule. After the while, you want to realize that actually chain rule is like differentiation by using a suitable substitution. Right? In the case of integration, you have a substitution method right now. Actually, chain rule is differentiation also using substitution. Just that we will do it the way Brandon did it. How do you do it? No, we learn a rule of thumb. We will say, bring down the power, copy the same, powerless one times differentiate inside. That's actually chain rule, right? Bring down the power, copy the same, powerless one times differentiate the inside. If you have a function that is more complex, and then you realize that they are all together more than 2 layers. And then you learn that you always do from the outermost layer to the innermost layer. Now we bring up power, copy the same, power less one, different inside, then to different inside, again the sign cube, right? You bring up, and the story goes on. Okay, maybe it's a bad example. Given that you asked us, I'm going to put a 1 in front. Do you know that some books describe chain rule as what? Okay, let me see if you can see this diagram and can make up what this object is. No? In Malay it's called, if I correct right, it's bawang. In Malay. Hey, you know what?
Malaysian.
Oh, okay. So in Malay it's called bawang. Okay, bawang. You know like onion. Why they call it onion rule? No? Because when you eat onion, right?
Yeah, you pay outside. Yeah.
My daughter say no, you just cut.
The question is who is eating onion raw?
Okay. So I'm sure you know how to do chain rule, right? So it's a recap. Let's do this question. Can you try this question? To find h prime of 1. And then once you're done, I want to class to echo your answer in unison, Example 8, try.
So trying to figure out the differentiate x e to the x.
Okay, when you differentiate e to the x, it's just e to the x, no change.
Yeah, I know. I'm trying to find the proof of it.
The proof of it. No, you should try on your own first before you go to Google. You should, try on your own right now, is it?
Yeah, I'm trying.
Okay,
I already tried already.
This one part is stuck.
Yeah, I'm stuck at limit hit. At the part where it's just basically I need to prove this
So it's
is
not so
one.
straightforward, true.
I'm trying to think if I can use squeeze here, but I can't find the two formulas to squeeze.
You can try at home, Yeah. In the meantime, you've done number 9, number 8,
Nope. Nope.
Okay.
The moment you did not say I start, it's like a challenge.
Zoe's friend, you've done 80.
Zoe's?
I forgot her name. Qing Wei.
No.
No. Give me a hint. Jingwen used to be sitting here, no? Yeah, when you sit here, I remember. Jingwen, 你做好了没有 You're done. Okay. Tyler, you know how to do not? Do you know how to do this question? Okay, on the board. Tyler, you were SAP student before?
No.
Never?
Hello. The other one.
I keep thinking that this Tyler, is not familiar. Katie, can do the next question, is it? Sure.
Would it be easier to prove 1 over ln x first? Would it be easier
I don't
to
think
prove?
so. No, cannot.
Yeah, would it prove that differentiate ln x equals to 1 over x?
Cannot. If you prove that ln x is not x, or prove this one, is it? I think it's harder.
It's harder to prove ln x first.
Okay, so I guess I can hear the clapping as the echo for the answer 21. Who didn't get 21? It's 21, it's true. He got it right. 21. And it's exactly his car working. Then let's come to example 9. Wait, example 9, example 9 is a bit tedious, no? Okay, we will end on example 9 to let you go off early to prepare yourself for PE because some of you take a while to change into PE gear. Okay. So to find f prime x, right? F prime x is g prime times the, okay, this is f prime x. To find f dot prime x, right? You use the product rule, differentiate the first, keep the second, plus keep the first, and then keep the second. So altogether you will have okay, so we will end here so that you can go for your PE on time. Okay, class is dismissed. Goodbye, class.